I may have a look for that I need to grab. So what am I looking, what's my look for on number 1 that I can use? What do we have there?
Reflexive.
We have reflexive property. So I have, they share this side in the middle. So how are these triangles congruent? By what? Look at one triangle. Side, 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 yeah. Side, side, side. On number 2, now on this one, I again have reflexive, but what happens when I look at the pieces I have and in the order that I have them, what does that give me? It gives me angle, side, side. Can I use angle, side, side? No, because I wouldn't even want to write the word on my paper, right? We can't write the word down. A, angle, side, S, side. Okay, this is not congruent or none. On 3 again, reflexive. There's reflexive again. Can I use this one? What order does it go in? Side, angle, side. And here, reflexive, and can I use it? What order does it go in? Angle, side, angle. On 5, the look for changes. What do I use here? Vertical angles. So I know that these angles are congruent and I get angle, side, angle. Same idea on 6. I know these angles are congruent. And this is angle, side, angle. This one's side, angle, side. Now 7, I think this is the first time we've seen this. So we see that they have matching sides. They have 2 different, it's like a lag, huh? They're lag. There's 2 different matching sides. And then there's matching angles. But are they in the same order?
No.
No. So this is none. They're not congruent. It would have to go, if it was correct, it would be this angle that would be marked instead, so that they both went side, angle, side. This triangle goes side, angle, side. This triangle goes angle, side, side. Okay, so not only do they have to have the same parts, but it has to be the same order. And then 8 is again reflexive and a side, side, side. They share this side in the middle, and they're congruent by side, side, side. Okay. Let's look at the warm-up that was meant originally for the 18th. I mean, we can go through this first page, I guess, but I want to look at the second half of it, which is on the back. This is the same idea. Let's run through it real quick. Where we have reflexive here. Actually, let's not do that. Let's do it. I don't want to say things. Go to the back. This is just like the homework, and I know the homework was a little tricky. So on the homework, we were using this. If sides, then angles. Okay, or if angles, then sides, vice versa. Or if I have an equilateral triangle, then I know all my angles are 60. So on this first example, I have sides here. So I know these angles are congruent. Okay, the base angles across from it. I also have sides here in this triangle. So using this length and this length means these angles are congruent. Okay. Now I can start kind of in 2 places. I could get this angle, or I could move here and get X. The way that I could move here is knowing that if that's a 90-degree angle and I have 30 degrees here, then how many degrees must this angle be? Right here. 60. Yeah, this angle must be 60, which we just marked that those are the same. So if I have 60 and 60, that's 120. And that leaves me with how many degrees here? 60, yeah, 60, 60, 60. This must be an equilateral triangle. So X equals 60. We don't even need to find this, right? There's no variable here. If I wanted to, I could go, well, this is 30, which leaves me with 150 between these 2 angles. And then dividing that in half would mean I'd have 75 for each angle there. Okay, if I had another variable there, I can solve for this because I know it has to be, this 150 has to be divided up evenly. Okay. Moving to 2, if sides, then angles. So I know that this is also 56 degrees. And if I have 56 and 56, well, that's 112, which is going to leave me with how many degrees there? That top angle of the triangle, 68 degrees. And then I have vertical angles. So if this is 68, then this is 68. And then again, I have sides, so angles. So X is also going to be 68. Right? See how that works there? Let me do a couple more with you and then I'll let you try 2 on your own. Let me jump to the bottom part. On the bottom part, it gives you, the setup's a little different. So I'll look at 6 here, where it tells me what this angle 2 is instead of writing the expression in there. But it's using the same concept. So if sides, then angles. So those angles have to be the same. And so I've used 100 degrees. What must each of these angles be? Not 25. I have 80 degrees left. 40 degrees. So I know that this angle is 40 and this angle is 40. And then I know that 5x plus 5 is 40 now. Okay, that this angle 2 is 40 degrees. And I can solve from there. So it's a little bit like an extra layer where I'm not just finding the angle, but then I'll have to solve after I find that angle. So I'm going to give you a few minutes to try a few more on this page with this angle side stuff, and then we'll go over the homework and see how the rest of this warm up. So on 3, if sides then angles, so I have 65, 65, fill in this angle. This is 90, so it leaves me with 40 degrees for X. We just talked about this one. This one's a little different, so I can see I have angle side angle here, so I know these parts are congruent. 5 just goes backwards, so if angles then sides, so I know my sides are congruent. We'd already done 6. And the last 2 are equilateral triangles, so that marks all 3 sides the same, so it'd be 60 degrees all the way around, and you solve for X, different expressions on each of them. And that's how you get your variable value there. So let's look at, so first of all, let me, since it's here, this is what you're going to be working on tomorrow. Now let me see what I put in, because this is longer and I don't think I even put a due. So let me see, what did I put in here? When did I put it due? Go over. Okay, so this is what I'll say. We are going to take the assessment on Friday, but there's a lot here. So let me put in that you should do, submit in here part 1. There's 2 parts. It says part 2 at the beginning of one of the pages. And then on Thursday, I'll say finish homework number 30. Oh my God, part 2. Okay, so in terms of what you need to submit tomorrow, it's going to be the first part of this review, which is like the first couple of pages. And that's for attendance, so it needs to be submitted by 3 p.m. that day. Okay. All right, so let's now talk the homework that you did last night, and that's the end of this unit. Friday, what do you need to do? Take a test. You have to zoom in on Friday during class time. There's the homework in here. There it is. So you have homework 29, using the same stuff, if sides then angles. So I'm going to just kind of talk through what you should have here and how you get those values. It's so similar to the warm-up we just did. So like on the first one, if sides, then angles. So I have 70, 70, which is 140. Leaves me with 40 degrees in that triangle. This has to add up to 90. And then again, if sides, then angles, so x must be 50. I also talked about figuring out which angles are the same yesterday. So remember, it's the angles across from those sides, or you can think about it that these angles have to be on the side that's not marked. So they're attached to this unmarked side. So like here, if I see that these sides, my angle should be on a side that's not marked. So 59, 59. Okay, those are the two angles I know there. 59, 59, which gives me, oh, let's see, 118, and leaves me with 62 degrees here. How would I get this angle? Or what would that angle be? 28, yeah, because it has to add up to 90. So these 90-degree angles are there to help me kind of move to the next half of that problem. Now this is a little tricky. So I have 28, which means remaining in my triangle between this angle and this angle, I'd have what, 152 degrees remaining in my triangle. I see that I have sides here. This is my unmarked side, so these angles must be the same. So that means I'm dividing that. Okay, that's how I get these angles. But this has to be broken evenly between these two angles. What would be half of 152?
126. Or sorry, 20.
No, you're doing like the 50. Well, okay, so you're doing 52. You have to do the 100 too. So half of 100, 76. Yeah, there you go. 76. So x equals 76 here. Okay, so 3 is pretty similar to this first one. If sides then angles, 74, 74, that's 148. It's going to leave me with 32 degrees here. This is a 90-degree angle, so this must be 58 degrees to make up the 90 degrees. Oops. This uses vertical, so if sides then angles, 74, 74 again is 148. That leaves me with 32, which makes that 32. And this would also be 32 because the sides match, the angles match, which is 64 altogether, and leaves me with 116 for my top angle in that triangle, adding up 64 and 116, adding up to 180. Now 5 is similar to that funny one on our warm-up. So if angles then sides, if angles then sides, so this is showing that these two sides must be the same, and then x equals -5. 7, if angles then sides, 2x minus 7 equals 5, x equals 6. 6 again, so this is using if angles then sides, if angles then sides, these sides must be the same. If angles then sides, -18. Okay, so that's that first page from homework last night. Let's see, back page goes back to the bottom part of that warm-up. So finding the angle, these are both equilateral triangles, these top two. So I know it's 60 all the way around. And so I just need to set my expression equal to 60. So on 9, you should have had x equals 5. And x plus 70 equals 60, x equals -10. 11 and 12 use that kind of same idea, but they're not equilateral. This is again using if sides then angles. So if I have 86, that leaves me with 94 degrees left in my triangle. Then I have to take half of that, break it up evenly between those angles. So that's going to give me what, 47 for each angle. And then x plus 57 equals that angle. X equals -10. 46 degrees here. So how many degrees would be left in my triangle? I have 46 degrees here, remaining in my triangle would be 134. Divide that in half, it's going to be 67. 9x minus 5 equals 67. 9x equals 72. X equals 6. X equals 8. Okay, that was the homework, if sides and angles. And you'll see that on your test. So you want to make sure you have all the notes, so you have all the examples, the warm-up, the homework, all of those pieces to be able to pull from as you're doing your review. So today, we're adding in our last piece in our notes, which is notes number 5. So far, we have 3 ways to prove triangles congruent, and we're adding 2 additional ways to prove our triangles congruent. It's really annoying that that won't go away. It's in the middle. Okay. So 2 more ways. So far we have side, 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 angle, side, angle, side, angle. We are adding to that angle, angle, side, and hypotenuse leg. Now this last one is a little bit special because it's the first one that's just 2 things we're looking at, but it's actually still 3 items. 90-degree angle is the 3rd piece, okay? So the reason that angle, angle, side works is really it's angle, side, angle, kind of disguised. And so, and I won't write out all these givens again, but if I had an angle here and an angle there, and an angle here and an angle there, and they were the same. Well, if 2 angles between 2 triangles are the same, then the 3rd angle must also be the same. Okay, this angle must also be the same. This angle congruent because a triangle equals 180. Okay, so if a triangle has to add up to 180, there's only one value that I could add in, and if these are the same value, it has to match. Okay, this is because 2 angles congruent in a triangle means the 3rd angle also has to be congruent. So if I ever have angle, angle, and then sides, like that, we can use it because we know that that means this angle is also congruent, which really gives me angle, side, angle. So we don't need to say it. We can use angle, angle, side, knowing that this must be true. Okay. Now the other one works really because of the Pythagorean theorem. So we can use hypotenuse leg. Now this is important. In a right triangle only, there's only a hypotenuse if it is a right triangle. Okay. So if the hypotenuse and a corresponding leg of 2 triangles are congruent, then the triangles are congruent. To use hypotenuse leg, you need to first show that you have a right angle in both triangles. And you still need to show 3 things. There's still 3 things here, even though it's just 2 letters that we list. Okay. So if I have a hypotenuse of my right triangle is the same, and one of my leg matches, okay, this must be congruent because a squared plus b squared has to equal c squared. So if I have 2 out of 3 of those things matching, if I have a hypotenuse and a leg matching, well, the other leg must match 2 in order for that to be true, which is true for right triangles. There's only one way that this would be a right triangle, and that would be that all three sides match. So really, it's showing side, side, side. But we can use instead hypotenuse leg. Okay. So I want to just look at the hypotenuse leg one. We'll add the angle side in when we do some other proofs. This proof got pushed up. I'm okay with not doing it. We'll do the second one on this back page here. So I want to show you how when we write our proof, we still need to list three things. On the bottom here, write your two columns, statements, reasons, MD is congruent to MA, given. I'm going to mark that, MD, MA. MN is perpendicular to DA, given. MN is perpendicular to DA. What does perpendicular mean? What does perpendicular mean? It's creating a what? Not parallel, but perpendicular. They're meeting at a 90-degree angle. So knowing that this is perpendicular to that tells me that these angles are right angles. So I should follow up and say that then angle MND and angle MNA are right angles. That is the definition of perpendicular. Okay. I've used, so with midpoint and bisect, we just have one follow-up. We've only used perpendicular like once, maybe twice this unit. By perpendicular, it's great to say that I have those right angles there, but I also need to say those angles then are congruent. So I follow perpendicular with two items where I then say, well, okay, so then those angles are congruent because all right angles are congruent, meaning they're all congruent to each other. If they're both right angles, then they are equal to each other. Okay, those are double follow-up for perpendicular. So there are my givens. Do I have a look for here?
Yeah.
Yeah, what do I have? I have reflexive in the middle. They have this side they're sharing. So I can say MN is congruent to MN by reflexive. Now, before notes today, that would have left me with angle side side, or the bad one that we don't want to use. In fact, hypotenuse leg will always look like the angle side side case we don't want to use, which means we can only go in this order, angle side side or side side angle, if we have a right angle. So because it's a right angle, I can say that my triangles are congruent. That triangle MND is congruent to triangle MNA by hypotenuse leg, because what I do have is a right angle, the hypotenuse is matched, and this leg is the same. Now, when I list the three things in parentheses, I'm still going to list three things. So I'm going to list the hypotenuse first, which is in step 1. Then I'm going to put where the matching leg is, and then I'm going to put where the 90-degree angles are. Okay, that's the order I go in for those three pieces. So I have my hypotenuse is in step 1. The leg is that step 5, and above it, step 4 is where I said my angles were congruent. So even though I have 2 letters, I still list 3 things. Now that's not what the proof was asking for. We still have 2 more steps here. It wants us to prove that n is a midpoint down there. Well, now that we know our triangles are congruent, we can say that this length is equal to that length. That dn is congruent to an. And what do we write there when we put a part is congruent? C, CP, C, PC, okay, from yesterday. So if we're listing a part afterwards, we can say CP, CTC. And if those are congruent, well, then I can say that n is the midpoint. It's like going backwards with that definition of midpoint. Okay, this time, since I know those lengths are congruent, then I can say it's the midpoint. That's the definition of midpoint. Okay, flipping that around a little. Okay, so I'm not exactly sure which ones I want you to do on the next page. So I want you to try a few of these on your own. Let's see. So if you flip this over, it says angle, angle, side, hypotenuse, leg proofs.